All right, guys, these are your video notes for the air around you, guided notes. So make sure you have your guided note sheet out. And as we go through the presentation, take notes on your guided note sheets, filling in the blank and adding notes where necessary. So take a moment, write your aim, which is what are the characteristics of our atmosphere? So at various points, if you need to pause to make notes, do so. Otherwise, let us begin. All right, so we're going to go through the composition of our atmosphere, and we're going to look at some characteristics of our atmosphere. So let's begin with what the atmosphere is made of. So the atmosphere is made of a mixture of atoms and molecules of different kinds. So let's talk about two terms, atom and molecule. So from chemistry or physical science, you should know that an atom is the smallest unit of a chemical element that can exist by itself. There are smaller subunits of an atom, which are quarks, but again, they do not have all of the same properties of the element. The second item is molecules. This is made up of two or more atoms. So a single atom by itself is just an atom, but when two or more atoms come together, they form a molecule. So as we talk, this first section is going to be looking at gases in dry air. Emphasis here on the word dry. So looking at dry air, it is normally composed of about 78% nitrogen, 21% oxygen, and then one all other gases. So if you look at the table here on the right-hand side, it breaks down all of those other gases by percentage. So you can see parts of it have argon, carbon dioxide, neon, helium, methane, krypton, and hydrogen, but in very, very small amounts. The main two would be nitrogen and oxygen. All right, so let's go through these different items and talk about their importance. So number one, let's talk about nitrogen. Nitrogen is the most abundant gas in our atmosphere. It makes up a little more than 3/4 of the air we breathe. But again, we don't use nitrogen in our respiration. We use another element, which would be oxygen. So oxygen is the second most abundant gas in our atmosphere, and it makes up less than 1/4 of the volume. All right. So oxygen is very important. Plants and animals take oxygen in directly from the air and use it to release energy from their food. So we use it through respiration, where we take oxygen from the atmosphere, which puts oxygen into our blood, and then we exhale carbon dioxide. So that lets us keep going. All right. So we're talking about burning fuel, so because we all use that in our bodily processes. So any fuel that you can think of, from gasoline in a car to candles on a birthday cake, uses oxygen as it burns. You've all put out a candle by covering the flame with a lid. Same thing with campfires. If a fire gets out of control, you can stomp it, which is essentially removing all of the oxygen from the area that is on fire, or by covering it. So without oxygen, a fire will go out, and burning is a chemical process that uses oxygen quickly. If you think back to chemistry, chemical reaction would be known as combustion. So anything that burns is going through the chemical reaction of combustion. All right. So some other characteristics of looking at oxygen. So oxygen molecules have two oxygen atoms. So like it says here, it is broken down as O2. So that is a typical oxygen atom. Ozone is a type of oxygen atom, but ozone has 3 oxygen atoms. So notice the way we write ozone. It will be O3. So that's saying there are 3 atoms of oxygen in one molecule of ozone. So have you ever noticed a pungent smell after a thunderstorm? You may not have if you don't have a great sense of smell, but if you have, this is actually the odor of ozone. And this odor is released when lightning interacts with the oxygen in our air. So next time you're outside after a thunderstorm, take a breath, see if you can smell anything. All right, so let's do a couple review questions. So pause the video and go back, refer to your notes, and try to answer these questions. What is the most abundant gas in our atmosphere? Pause the video, try to find the answer. All right, answer would be nitrogen. Number 2, why is oxygen the most important? So again, pause the video, try to come up with an answer. It is essential to plants and animals, and it is involved in processes such as fire. Final question, what percentage of air is made up of carbon dioxide? So again, pause the video, flip back to the table. All right, you should have found 0.036%. All right, so we've talked about the big two. So now let's go look at the other atoms and molecules that make up the air we breathe. So let's begin with carbon dioxide. All right, so carbon dioxide, this is an element or a molecule that is essential to life. Again, the chemical formula here would just be CO2. 1 atom of carbon, 2 atoms of oxygen. So plants have CO2 or must have CO2 to produce their food. This is the chemical process they go through, like photosynthesis. They take in carbon dioxide, they go through photosynthesis, and they release oxygen, which lets the rest of us keep breathing. So when the cells of plants and animals break down the food to produce energy, they give off CO2 as a waste product. Also, when fuels such as coal and gasoline are burned, they release CO2. So burning of any type of fuels increases the amount of CO2 in the atmosphere, which on its own is fine. We have plants, and we have large numbers of plants to help take that carbon dioxide and convert it back to oxygen and remove that excess CO2 from the atmosphere. All right, so here's a picture of the CO2 cycle. So animals and looks like humans here, if you look over to the right, are releasing CO2 in the air. The plants are producing their energy through photosynthesis, which takes carbon dioxide from the air, releasing oxygen. And then your animals are able to consume energy from plants, and it's just one big cycle. So we'll look more at that when we look at the carbon dioxide cycle and the carbon cycle and the nitrogen cycle. All right, so let's look at some other gases. So oxygen and nitrogen make up 99% of dry air. So argon and CO2 make up most of the other 1%. But if you refer back to the previous table, you'll know there's 4 or 5 other elements that are found in trace amounts in our atmosphere. Which brings us to the remaining. So the remaining gases are known as trace elements because there's only a small amount of it present. All right, so everything we've talked about thus far is related to dry air. So we know that not all air is dry, so let's address that. So let's look at water vapor. So like I said, thus far all we've talked about is the composition of dry air. In reality, air is not dry, it contains water vapor. And water vapor is the water in the form of a gas. It is invisible, you can't see it. Here in the summer in the South, we definitely know what this is. This is what, when we have large levels of this is when we have very high humidity, which is when your sweat can't evaporate and you just get really hot and sticky. So this is not the same thing as steam, which is made from tiny droplets of liquid water. So again, water vapor is the invisible gas that is in the air. We're not talking about steam produced from boiling water. All right, so the amount of water vapor in the air varies greatly from place to place and time to time. As you know, different biomes have different types of weather. So that influences the next point. Water vapor plays an important role in the Earth's weather. So the more water vapor in the air, the more likely it is to rain. And we have something else that comes in here. So clouds form when water vapor condenses out of the air to form tiny droplets of liquid water or crystal ice. So if there's enough of these droplets and they become heavy enough, they will fall to the earth as precipitation, which could be in 2 forms. You can have precipitation in the form of rain or precipitation in the form of snow. All right, so that pretty well addresses the vapor component. Now let's talk a little bit more about particles that are in the air. So far we've talked about dry air and then air that includes water vapor, but there's other items that are in the air that we breathe all the time. So pure air contains only gases, but pure air only exists in laboratories that we've purified. In real life, it's going to contain particulates or particles. So these are going to include the following: dust, smoke, salts, and a variety of other chemicals. We talked about this in the previous intro item on the characteristics of atmosphere. So we've got volcanic ash here on the right, sea spray here going toward the middle, smoke from fires, and this looks like some type of chemical, like methane explosion, or maybe sand being thrown up from a dust storm or a tornado. All right, so final bit here, importance of the atmosphere. So as we all know, the atmosphere is extremely important. If you go take a look through our solar system, there are not very many planets with atmospheres such as ours, which leads to the fact that this is the only place we currently have to live in the form of a planet. So the Earth's atmosphere makes conditions on Earth suitable for living things. Without the atmosphere, it would not be so great for us, because again, we currently don't have another place to live. So that wraps up this. So roll into the next assignment, posted via Schoology. If you guys have questions, send me a message via Schoology. Thank you guys. Bye-bye.